me to do? You want me to do the tic-tac-toe question, and what a surprise, the taco caddying question. So, first I will do, wait, hold on. What's the prompt for tic-tac? So tic-tac-toe wants you to create an object called tic-tac-toe, right? And it needs 3 properties on it, right? It needs a board, and it needs 2 methods. And methods, as you guys know now, are functions, right? They are functions that live in objects. So the first prompt was just like, use this, create a board that replicates a tic-tac-toe object, right? So we can do board is an array is an array of arrays where all the values are null. That is what the prompt asks you to do, and this is literally what it is. Does everyone agree with me? Does everyone see how this looks like a tic-tac-toe board? And the reason we put null here is because null is like nothing, right? There is nothing there. It is an empty space, okay? So, now, that was the easier part. If you guys struggled with that one, it was probably because of the wording of the question, where don't feel ashamed at that, okay? So these questions probably haven't been looked at in a long time. However, the real problem started with the move function, right? The move method. So the move method would probably have given you guys a lot of trouble if you tried to use arrow functions, okay? And I don't know, did Robin go into why arrow functions are no good, really, when using this? He talked about that, right? Good. Now you know the main difference with the function keyword and arrow functions. So I will be doing this problem and the other problem all with the function keyword, okay? Because if these methods were called outside of this in the global scope, then the Windows this context would be passed down into that instead of the original objects, which is not what we want. So we will do move. And this is going to be a function, an anonymous function. And this is going to take 3 things. It's going to take a character, it's going to take a row number, and it's going to take a column number, right? So we say if this dot board at row at column is equal to null. If there's nothing there, we can do this dot board at row at col is now going to be assigned to car, right? If this dot board at the row at the column is null, if that value is triple equals to null, that means that that's an open space. So we know that it's a legal move to play there. And we just reassign that value, the same thing, to whatever the character was, right? An X or an O. So now that we have that, then we return this dot board. 2 lines. Does anyone have questions on the move method? Think about it. Anybody have any questions? Yeah.
Is it valid to do it with splice? Or is that just less efficient?
Splice?
Yeah. I solved this and it ran for splice.
Well, that's just more of a headache, right? I mean, you can, like, we can, since we have the row, we can pull out this array, and we have the column, right? So we can just go to that index, splice it out, and insert whatever we had, only if it's null. It would be the same check here, but this would be just a splice, right? So you can do that if you wanted to, for sure. Okay, so now the clear function actually should have been pretty straightforward. Because you just do this.board is equal to that. Right? Clearing means we want all of the past moves gone and we want a new board. Our new board is here, so we just hard code it again. And then we return this dot board. And there we have our tic-tac-toe, bless you. There we have our tic-tac-toe thing, our object with two methods in it. Any questions before I do Taco Cat Inc? Dope. All right, cool. So, Taco Cat Inc. is just like an annoying problem, honestly. I think I need it gives you like this giant abysmal thing, right? This giant object with multiple objects inside of it. And I'll just put it right here. Okay, I'll put it right there. Before we go into the problem, let's just look at this object real quick. How many key value pairs does the object Taco Cat Inc. have? 5, right? Don't be alarmed by these, right? It's actually 5. We have the key of gourmet shell and the value being one object. Key of gourmet fish filling, value being one object, so on and so forth. And then the key cache with the value 0. So the first question that we wanted to do, right, was to find the total like inventory worth. And this might have been easy, right, if you could just loop through all of these objects, because you know that it has a cost quantity, you know you just have to multiply them together, yada, yada, yada. But the problem is cache, right? Cache doesn't have a value of an object. So if you try to look into the cost property of 0, it just doesn't exist. So it would just get an error, right? So a way we can do that is in a for in loop, we have the key that's being stored during every loop, right? So we could just check literally if the key is equal to the string cache, because all keys in JavaScript of objects are strings, right? They're all strings, okay? You can just omit the strings when you put them. I don't need this here, right? I can get rid of this, and it's still fine, okay? Right? So, and we wanted to add these methods onto the actual object of Taco Cat Inc., right? So we do Taco Cat Inc. dot current inventory is going to be equal to a function. And this function is going to want to get the value of all of the inventory, right? So we can first say let total equals 0, because we know we're going to have to add things up together. So it's just right away I'm thinking, okay, a total variable, right? We need something to store our math, okay? So we can do for let key in, I can say Taco Cat Inc., or I could say let key in this, because this is actually referencing the exact object Taco Cat Inc. This and Taco Cat Inc. are the same thing. They're referring to the same object, okay? So let key in this. This is just a shortcut, right? So let key in this. If key is not equal to cache, that means we must be at one of these. Then we can do some stuff, okay? Because if it is cache, we don't want to do anything, because that has nothing to do with the inventory, right? So if key is cache, we say, well, since these are all hard-coded, so this at key will give us this object, right? So we actually have to do a for in loop through these things, right? So we could do for let deeper key in this at key. So when we loop through this, we can do total is now going to be plus equals to this at key at deeper key dot cost times this at key at deeper key. What did I miss? Yeah. At key at deeper key dot quantity, right? Then at the end, we can just return total. So if we did taco cat dot current inventory and invoke that, we would get 1710, right? Looking closer at this, we have a for in loop to loop through the outermost object. If we're not at cache, we must be at a key that has an object for a value. But we don't know how many things are in there, so we have to do another for in loop. And we have to call that thing something different. So I called it deeper key. Because if I called it key and I was trying to do this at key, because of scope, it would never be looking at this key. It would always be looking at this one, okay? So I called it deeper key, right? So we have total, we have this at key at deeper key dot cost times the same thing dot quantity, because we're at the same object now, and we add it to the total, and we do that over and over again. Any questions on this? I think the solution like pulls out all of these things and puts them in variables that makes it more clear for you guys, but I did it this way. Any questions? All right. So now the next part is going to be the sale function, right? So the sale is supposed to return the final price. So we're going to have to look through, see how many things that they're buying, and then subtract the quantity from what we have in our storage, and then return to the customer the final price, right? So, wait, let me give you, I think, sale. Yeah, so like the order would look like this, right? This is what the prompt tells you, that the order is going to be an object that looks like this, right? So going off of that, we can do taco cat inc dot sale equals a function, right? Taco cat inc is a function. Sale is a function. And since we're returning the final price, we know we have to add something up. We have to add things together to get a final price, right? So what does that sound like? Let final price equals 0. We should define a variable to store all of our math in it, okay? So now we have to do a for in loop. So, and this takes an order. That's my bad. So now we do a for in loop, right? So let key in order. So the key will be the gourmet shell, and order at key will be hard treat shell. Hard treat shell is something up here. Ooh, so how can we use that to find out how much it costs and how much to remove, right? So we say, I'll pull these out for you guys. Let choice equal order at key, right? Now that we have that, we can say final price plus equals, we can use the this keyword again, this at key at choice dot cost, right? Because the key is gourmet shell, right? So this is still Taco Cat at gourmet shell at hard treat shell, which is the choice, right? That will give us this object, and it will have a dot cost, right? So we add that to the final price because that is in the order, okay? Oh yeah, and then we have to do this dot cash plus equals this at category, this at key at choice dot cost. Nope. Dot cost. Because now our Taco Cat Inc., our company, has more money, right? Is everyone following me? And now we do this at key at choice dot quantity minus minus. Because we have lost one of those things, okay? Then, out here, we just return the final price. So, the order looks like this, right? We loop through the order first. The choice will be order at the key. The key, let's say, is gourmet shell. So the choice is hard treat shell, right? Then we add, then we need to get it to the final price, right? So we look back at Taco Cat Inc. Gourmet shell is a higher key inside of Taco Cat Inc., right? It's one of the key value pairs in there, right? So gourmet shell is here. So we have the key here. So this at key, right? This at key at choice. Choice is order at key, right? So hard treat shell. So Taco Cat Inc. at gourmet shell at hard treat shell dot cost. Dot cost will be added to my final price as the customer. And then your Taco Cat Inc. will get that money as cash. So we do the same thing except we're adding to two different things. But then, since we added one thing, we have to remove one thing from the quantity because this is a business, okay? Does this make sense?
Does the problem give you order?
Yes, it is in the prompt, in the README. Here. So you order twice, you still get 7 out because that's the final price, because that's what we're returning. But the quantity will go down. And our cash is 14, right? Any questions?
Can you go back to this?
Hell yeah. Nope. Nice and easy. Just kidding. See, like, I chose to put this out here because this looks stupid, okay? And it's hard to read. So right now is a great example of why pulling things out and putting them into variables and naming that variable something that will make sense to you as a person will make your life easier when looking into deep nested objects, right? Because otherwise, this is annoying, okay? And if I came over to help you guys with this problem, I'd be like, what are you doing? I have no idea what you're trying to do. It's just hard. You're just going into something, and it doesn't sit well, right, with normal people. If it does sit well with you, I'm not calling you not normal. I'm just saying. Okay? You understand what I'm trying to say, though, right? Sometimes even though I'm not a fan of pulling things out and putting them into variables because it's more writing. It's another line of code. It's another line that the computer needs to read. But sometimes it just makes a lot of sense, okay? Any other questions before we get into the lecture? Yeah.
Would you recommend using key? I know key can be any word. Would you recommend using the word key or using a certain instance-specific word for that in general?
So it's up to you completely. Like I said, it's just variable naming, all up to you. I personally always use key. Just because I know it's an object and this is the key in that object. And I know what the keys are supposed to be, but when I'm reading down my code, I know that, okay, now I need the key, so I'm just going to type in the word key, not some weird thing that I decided to call it that time. Sometimes it makes more sense to call it something else. Okay? Did you guys have some problem where you had to do the days of the week kind of thing, attendance?
Yeah.
See, there, like, I think there was, like, you would call the key day. That makes more sense there. You know what I mean? Because it's a weird question, and there's a lot of different keys and a lot of different objects. But I know that this is going to be the day, right? So it depends. Any other questions? Cool. All right. So today, just comment all this nonsense out. Can everybody see the board? All right. So today we're going to talk about reference versus value. Okay? What do I mean by that? So there are primitive data types, right? So when you assign something, a variable, like what am I doing right now, right? If I'm saying let prim num equal 10, right? And then I'm saying let prim copy equal prim num. And then I'm going to do prim num plus equals 50, right? And then if I console.log prim num and I console.log prim copy, I would get 60, and then I would get 10. Because when I assign prim copy the value of prim num, because it's a number, it's primitive, that means its value is copied over and put into this new variable. There is no connection between these two variables, right? And then when I add 50 to prim num, we get 60. But as you can see, prim copy is still 10. This makes sense, right? This makes complete sense to you guys, right? However, this is only when we're dealing with primitive values, okay? When we are dealing with primitive values as in numbers, strings, and booleans, right? And null and undefined, but whatever. Mainly those three, right? But now there's something else, right? There's something else called complex values. Complex values as in objects and arrays. So, what if I said let's comp r equal an array of 1, 2, 3, right? And then I say comp copy is going to be equal to comp r. And then I do comp copy dot push, right? Then I console.log comp r, and I console.log comp copy. Ooh, I altered both arrays. This is very important to understand, okay? When I am assigning, oh, sorry, I forgot the let keyword. Yeah, sometimes you forget it and it still works. Don't worry about it. Anyways, when I am declaring this variable, comp copy, and I'm assigning it to comp r, I am not copying the value of that array. I am not doing that. What is actually happening is that I'm actually copying a reference to this array in my computer's memory. So basically, this array is living somewhere at an address in memory in your computer, right? The array is there. And then the directions to get there to that memory is you could think of as the reference. So when I'm setting something equal to that reference, that means that this thing basically has now a copy of those directions. But they're still pointing to the same variable, the same array, right? It's not a different array. And push mutates arrays, right? So as you can see, they are both affected, but it's not both, it's the same array. If I did I would get true. Wait, but I thought that array, empty array, triple equal empty array is false. Oh, it is false. But why is that true? It's because we are not comparing values. We are comparing references. Okay? That's what the triple equal sign does. It compares references. So on line 93, when I'm comparing two empty arrays, what I'm actually doing is comparing their points of location in memory. And these are array literals, right? They are two completely separate things. I just put one here, and I put a different array here. They're not equal. They're living in two different places. They're storing different things. They're just not related, right? However, here I have comp r. Here's one array, right? The address is now living inside of this variable. And then the address is then copied over into this variable, right? So and then when I do that, the year is in both variables now because they're pointing at the same array. That's why this is equal, because it's one array. It's only one array. Two variables, but one array. They're both pointing to that one array. Does that make sense? That is why that happens, and it is the same with objects. Okay? An empty object is not triple equal to another empty object. However, if you do the assignment this way, it will have the same result. And this is what I mean by reference and value, okay? With assignment. So like another example that I could show you really quick is, let's say that I have const alter r equals a function that takes in an argument, that takes in an array, and I just pop off the last thing, right? So if I have let example equal an array, I'll do 3, 2, 1 now because I'm really creative, and I do r pop, and then I can return r, right? And I say let what is this equal to alter r invoked with example and then I console.log what is this, but then I also console.log on the next line that example again. What we get, example was altered. As your functions get bigger, as your code gets longer and harder to read and more confusing because you're solving very confusing and hard to think about problems, you can see how this could be an issue. What I did in my function is I'm actually changing the value that was passed in, but what I thought I was doing, I thought I was just spitting out a new value. I'm not. I'm spitting out the same value. Example gets thrown into this function. So example is this array, right? And then I pop off that array. But it's not like, but R is another variable, right? It's a parameter. So that means that the value should be assigned to this and I can play with it. No. The value is an array. So the reference is copied over. So the array is doing something in some point in memory, and then I pop off the last element. And then I'm going to return that same array. I'm not returning a different array. I'm returning the same array. So as you can see, both are altered, and both are equal because it is the same array. So what's a way around this? How can we do it? It seems like nothing could. This is just a problem, right? We can't program anymore. It's over. We have to learn a different language. No, I'm just kidding. So basically, a way to do this is, what if I was just like, R is now going to be equal to r.slice. Oh, I fixed it. Do you know why? Because slice returns a shallow copy of the array. It is a copy. Think of slice behind the scenes, making an empty array, looping through the original array, and putting everything into the new empty array, and then returning that new empty array. That's what's going on. Now, R is being reassigned to what it was, but .slice with nothing passed in. And if you don't pass anything into slice, you start at the beginning and go to the end, meaning it's the whole array. But slice returns a copy, a shallow copy, okay? Shallow copy. So, now, when I pop off of this, and return it, what is this is now going to be a brand new array, and example isn't touched. Yeah, right? Yeah. Yeah. Right? How do you guys feel about this? Any questions? Yeah.
Do you find that this is mostly a hassle when programming, or can it be beneficial? Like, can it help you?
I've actually been like really screwed by this once during work, but usually it's just like something I don't think about because it's just like it's kind of like common knowledge, you know. But when you start nesting things, like nesting objects and objects, and that's like important data, things get a little tricky like pretty quickly. Yeah? I don't really have a solid example to show you guys, but the main thing about, okay, I'll show you like one like little deeper example. So like let's say like really quick const deeper example equals a function, right? And it's going to take an array, and then we're going to do a for loop, right? For let I equal 0, I is less than r dot length, I plus plus. I forgot everything, right? Yeah, I just didn't put the semicolon. Okay. If, but first I'm going to do r is equal to r dot slice, right? And if r of I, I mean if array dot is array of r of I. So if this is an array, I will do r of I dot push mistake. Okay? What the fuck? Okay. Otherwise, I won't do anything. Okay? So now I say let other example equal to an array, and it's going to have a 5. It's going to have a string, hello, and it's going to have an array of true, right? True, false. True. Does that look good to you guys? All right. So now I'm going to do deeper example. Oh, no, wait. First I'm going, and then I'm going to return array here. And I'm going to do let new variable equal to deeper example. And I'm going to pass in other example. I have to work on my naming, honestly. This is stupid. But and then I'm just gonna console.log other example, and I'm gonna console.log new variable. And now you see why naming is important, because just looking down over here, like what the hell, what would you even think is I'm doing? Like you wouldn't know, right? But anyway, they both have the mistake pushed into that inner array. But I sliced it, right? And that worked before. When you slice something, it means it's a shallow copy. That means it looks at each value and makes a copy of that and puts it into a new array, right? But what if that value was an array? The thing that it copies is that array's reference, not the value. It doesn't keep going down, okay? Does that make sense? So slice, it's going to go through each thing in here, right? It's going to go through each thing in here, and it's going to make a new array for itself. Right. And it's going to say, all right, first variable I'm going to copy over is the 5. And I'm going to put it into that new thing that I created. The next thing I'm going to copy over is hello. It's going to go in that new thing that I created. Then it sees one value, one array. When I was assigning those things before, you remember that the reference is the thing that got copied into the variable, right? This is the same thing. The reference to this array living inside of other example, just the reference is copied into there.
So it's like having other example at 3.
Whoa. Wait, what?
Is it kind of like having other example with like brackets and a 3, just like
yes.
In there then?
Yes. So then, in my function, where I did the push, I wasn't pushing into this new thing's new inner thing. I'm pushing into other examples' inner thing. Yeah, for sure. So, like, I make the copy, right? Shallow copy, because that's what slice does. I loop through, and I check if array, right? And if it is, push in mistake, right? But this didn't copy the true, the false, and the true into a different array. This just copied the reference of this array. Slice, I mean. So when I push into that thing, when I find that inner array, right? Does everyone agree that's what this function's doing? It's looping through an array and looking for a nested array, right? Once I find that nested array, I'm pushing into that nested array, right? But that nested array isn't a copy. That nested array is the original nested array. So we have the same problem as we did way up before we did slice. If you have an object or an array or a combination of both nested down and down and down, and you want to replicate that thing without having references linked, you have to loop and loop and loop until you hit something that isn't complex. Does that make more sense? Let me just see if I got everything. These are the primitive values, right? String, number, boolean, undefined, null. Don't worry about symbols. And then we have objects and arrays and functions are complex. I'm not going to go over this. This is boring. Why do primitive values... Okay. So this, I think, is important. When you assign a primitive value to a variable, the variable stores a copy of that value. Let first equal 20. First stores the value 20. First equals 30. First now stores a new value 30. Second equal 30. Second stores its own copy of 30. Its own copy of the number 30, right? Second now stores a new value 31. And you can see that they're storing values, right? But here, when I do second is now equal to first, first stores the value 20, second stores its own copy of the value 20. So second plus plus has no effect of the value stored in first. You guys are aware of this, right? Like, this was never a problem before. However, here, can you guys see this? Here we have a middleman, right? We have a reference to this value. So let first stores a reference to this array, 10 and 20. So we have the variable first, and this variable is pointing to an address in memory, okay? A reference to this value, this complex value, okay? That is the main difference between complex and primitive values, okay? When you assign a complex value to a variable, the variable does not store a copy of the value. Instead, the variable stores a reference in memory, okay? So here, let second equal the same thing, except not the variable. It's a new array. Second stores a new reference to a new array, right? Since first and second reference different arrays, pushing a value into second will not affect the array referenced by first. And you can see that here, right? The reference here is 0x001. Here is 0x002. Don't worry about that. That's just like, it's just how it is. Anyways, they're pointing to different references, so that means they have to be different arrays. Does that make sense? Does this make sense up until now? Okay. However, things get... Does this make more sense now? This is what's going on actually. So since second is now being assigned to first, and first was assigned to this reference of this, and second's being assigned to first, what is first actually holding? First is just holding this reference. So that means second is now going to be equal to this reference. And both these are the same reference, so they point at the same value. Does that make more sense? Somebody say no, if they don't think so. Right? And now, so slice creates a new array. So as you can see, now first and second are pointing at different things, because here we did first dot slice. Right? That's the gist of how it works, right? So now, as you can see here, when we're passing primitive values into functions, we have my num equals 20. Then we have a function adds 20, which takes a number, adds 20, and then returns it. And if we pass my num into adds 20, we can see that my num is not being affected, right? I showed you this as well. However, when you do the same thing except change it around, now we're making a function that takes an array and it pushes 20 into it. You can see that the original array is the thing that is being changed. Because the same thing as variable assignment, when you pass variables into functions and it's a complex value, what you're actually passing in is a reference to that value. You're not passing in the value, you're passing in a reference, okay? The value stays put at a certain address, right? What you're passing in are the directions to that address. Does that make sense? A little bit?
Yes.
Nice. Nice. Equality operator will compare complex values by reference, not by value. Okay? So as you can see, since they share the same reference, array 2 is now going to be equal to array 1. They are actually equal. It's the same array. And if you think about it, this makes complete sense. If this was false, that would be really weird. They're either different arrays or they're the same arrays. Think of it like when you're thinking of numbers, you're just like, yeah, this is the number 10. This is like an abstract thing, right? It's just an abstract like number value. And yeah, it could be equal to a different abstract number value or not. But when we're talking about arrays, think of them as like solid things that exist in different places, right? There's this one and this one. They're different. They're not the same, okay? So, we showed you earlier that .slice creates a copy of the array. If an array has a complex value as an element, only the reference to that complex value is copied into the new array. That's why we say slice makes a shallow copy of an array. It doesn't make new copies of any complex value stored inside the array. So, let array 1 equals an array with two things in it. The number 1 and another array. Let array 2 equal array 1.slice. So array 1 and array 2 are different. They're different arrays. They're not equal to each other. However, if we do array 1.push 4, array 1 at 1.push 4, so we're pushing into this inner array, right? Console.log array 2 at 1 and console.log array 1 at 1 is triple equal to array 2 at 1. We get true, and we see the 4 is actually also in array 2. Does that make sense? That makes more sense. Any questions on any of these things? Primitive versus complex, variable assignment, passing values into functions, equality operators, and the .slice method. Any questions on these? Seriously, ask now. Otherwise, you can take a break. What's up?
It sounds like it's only important when you need to change the code, right?
What do you mean by that?
Because, I mean, the slice method is pretty cool, but then if I don't need to change the complex code that I already wrote, I don't need to make a copy of it, you know?
I mean, it just depends. Like, everything is different, right? Like, every problem is different, everything you write is different. So I don't really know, like, I can't give you, like, a good example of when this would be, like, the deciding factor. It's just, you need to know it in case you're experiencing side effects that you want of altering things you pass into functions.
Okay.
That is a big side effect. Like, because think about it, we're writing functions to like change data around, right? Like we're talking to like a backend server, and we're getting back like heaps and heaps of data, right? And we need to mutate it in ways that can be displayed to people and put it on a screen, right? But do we want, if we want to display the same data in two different places, but we have to change it a little bit to display it in one place and change it a little bit to display it in another place, do we want to change the original thing, or do we want to make a copy, a deep copy, right? Things can get lost over time, okay? It's important to know,
Okay. Thank you.
for sure.
This is how. Is this why the clear function with the tic-tac-toe, if you're able to just rewrite null, it would change board? That was a function.
Wait, what?
In the tic-tac-toe example,
Yeah.
is this why when you like the last one, you can just like rewrite null over and over and over again? Because it would change.
Well, that doesn't have anything to do with reference and value, right? Like, I'm pretty sure if you wanted to, you can do like a double for loop and loop through everything and just change everything to null and then return it there. But this is just easier, you know? This doesn't really have anything to do with the reference of it, though. However, the old board and the new board that I am returning are completely different places in memory, right? They do have different references. Right? Nice. Is everyone all right? Yeah.
You lost me on that last sentence. Why are the old board and the new board different? If you're reassigning this board,
I'm reassigning this board to this array.
right.
But the board before was this array. So aren't they different?
My understanding was that the functions within the methods within this object are mutating what is stored at the key of the board, right? Or they're changing it.
In move, yeah.
Like move is changing it, and clear is changing
Clear is just
that.
returning a new array with new arrays inside of it. And all their values are null.
It's not changing board back.
No, we're returning a new blank board.
Isn't that what Slice is doing also?
Right, but slice. Well, no, I mean like. Wait, what do you mean by that?
Isn't Slice doing what we're doing, reassigning it to a different array?
Well, yeah, but I mean slice would return a slice wouldn't change any of the inner values if we want to reset the board, right? Like if we did slice and there was like an X here and an O here, they would still exist down here. The X and the O would be here, right? Like that's why we have to return a new board, a new array of new arrays with the values null in them.
Oh, so is this board now pointing to a new place?
Yeah.
Is that what you're saying? Oh, okay.
Like if I did, I'll just show you, like right? Like if I did if I uncommented this, let prev board equal this dot board, right? But then I'm saying this dot board is equal to something else. So what if I did console.log prev board triple equal to this dot board, right? And then I called tic-tac-toe dot clear. False. They're not the same.
Reference is not the same.
Yeah. Nothing is the same except the inner values, the null. Everything else is just a new thing.
So move is altering.
Move is changing this null to something else,
Right.
meaning the arrays are still the same, right? The arrays stay in place. What we're changing is inside of the arrays with reassignment. And the clear function, we are still doing reassignment. However, we are reassigning it to a brand new array that holds brand new arrays.
So even in a case where you don't declare variable pre-board, that previous board still exists somewhere in memory.
Yeah.
Oh, okay. You're just not using it for anything.
Yeah, it's not like it gets deleted. I guess.
I thought the new disk board overrode it, but
Nah, it just like makes a new board and then assigns the board property that new board.
oh, okay.
Any other questions? Nice. All right, take 5 minutes. I'll slag out Paris and open the workshop.